Okay, we're gonna look at this next assignment. Of course, it's titled 7.9C, Mini Assessment 1. We're talking about composite figures. Okay, so composite figures. It says the figure is created by using two congruent triangles and a rectangle. Which is closest to the area? So obviously, closest means we're gonna get a approximate answer, or as we say, a más o menos answer. And so we look at our figure here. It says there are two congruent triangles and a rectangle. So obviously you can see there's a rectangle here. Okay. Of course, we find the area of the rectangle by base times height, and we can find the area of those two triangles. Okay, this triangle and this triangle by using base times height divided by 2. This one also, area is equal to base times height divided by 2. Okay, and so we got to think there, and it says there that triangles are two congruent triangles, so that means these guys are the same. Okay, so that means that this one is here. If this is 24, that means this one is also 24. And that means this is 20, because that's 20. And so all we have to do is find the area of the rectangle in the middle, base times height. So base times height is one answer. And then you find the area of the triangle by doing base, and then the height is right here. So base times height divided by 2. So for example, this one, base 24 times the height 9 divided by 2. So base times height divided by 2, you get an answer. You're going to get the same one over here because they're congruent. Congruent triangles mean they're the same. So that means that this answer and this answer will be the same. So base times height divided by 2. The area here is the same as this, and then this area, so base times height. And so once you get the answers to all three areas, you add them together. Okay. Number 2 there. If I look at the picture there, I see that there's a square in the middle. It's a pattern for a pinwheel. It was made by placing in 4 quarter circles. So that tells you how many circles you have, or part of a circle you have. 4 quarter circles and a square. So 4 quarter circles on the side of a square. It says there each side of the square is 3 inches. So we're going to look at the square, which is right in the middle, which is this one. That's the square. And so we're going to say the square, each side is 3. So obviously to find the area of a square is just base times height. Okay, now we got to find the area of the circles. And to find the area of a circle, it's pi times radius squared. For all these problems, especially if it says approximately, we can use pi as 3. So that's what we're going to do. We're going to use pi as 3. And don't forget, this means pi times radius. Now, if I think about a whole circle, okay, and these are quarter circles, that means I can divide this into 4. Okay, that means each of these pieces is one section. Well, if I put these 4 sections together, I actually have one full circle. So if I find the area of a whole circle, I have found the area of all these 4 together, because 4 of these will make one of the full circle. And so then I don't have to divide this by 4 or anything, just find the area of a circle, because all 4 total quarter circles make one full circle. Okay, now so you need to find the radius, because that's what the R stands for. So what does the radius stand for? Well, think about it. If I had the whole circle, okay, if I had the whole circle, which would be that, let's say I had this whole circle here, okay, does that 3, which is here, because that represents the radius or the diameter. In a circle, when it goes all the way across, that's considered the diameter. If it's from the center point to the outside, that's considered the radius. So this 3, would that be the radius or diameter? If you think that's the radius, we'll just multiply. Pi is 3 times the radius. If you think it's 3, well, let's put 3 there. If you think it's not 3, well then, if you think it's 6, then you would use 6. But think about it. If it's here, and it goes this way, or this way, or this way, these are all radii, and so they're radii, and each radii is equal to 3. 3 this way, 3 that way, 3 that way. So this is the radius. And so the radius is 3. And so you just put pi is 3, radius is 3. So radius times 3. Give you the answer of the four quarter circles. And then you add that to whatever you get for the square, which is base times height. Number 3 there. A composite figure contains a rectangle and a triangle. Okay. So we have a rectangle and a triangle. You have a rectangle, easy, base times height. You have a triangle here, base times height divided by 2. Base times height divided by 2. Let me write this again. Base times height divided by 2. So, if this is 20, think of what this is, okay? And so, use both areas. Get both answers to both areas and then just add them together. Base times height gives you one answer. Base times height divided by 2 gives you another answer. Add them together once you get the answer. For a partner pair was asked to create a composite figure. The figure they created is shown below. Okay, so the whole figure is this. Okay, so think of that. Think of that figure there. Okay, that looks like a rectangle to me. Okay, and so it says there, which best represents. Best means approximately or close or nearest or más o menos. Okay, so you can't just say base times height and find the answer. Okay, it's not that easy. Okay, so you have to figure out, okay, let's look at the design of this figure. That's what you got to figure out. What is the area of the shaded part of this figure? Okay. So to find the area of the shaded part, okay, what would you do? Well, you would have to find the area of the whole rectangle, okay, and then you would subtract it from the circles, or the half circles, to be more precise. Okay, and so think there. You need the rectangle is base times height. Base times height. Okay, base times height. So think, what is this measure? That's your base. Base times height. Okay, now those are two half circles. Well, I can use area equals pi times radius squared. I can divide by 2 because they're half circles, but if you think about it, if I put both half circles together, that's one full circle. So then I don't need to use divide by 2. Pi is going to be 3 for all the problems. Okay, what's the radius? Well, think about this. What is this? If I made the whole circle, okay, what would this be? This is the diameter of the radius. So what's the diameter? What's the radius? Put it in there. Do the math. Do the math for this one. Base times height, and then subtract your answers. And one of the answers will be the closest. One of those will be really close. Okay, number 5. Diana has a pentagonal garden. What is the dimension shown in the diagram? What is the area of Diana's garden? Obviously, we have a 5-sided figure because pentagonal garden. But if I decompose it or break it into 2 figures, I can see I have a rectangle, and I also have a triangle here. See? So I have a rectangle triangle. All I'm going to use is base times height, and in this one, base times height divided by 2. Okay. Base times height. One answer. And this one here's a triangle. Now think, where do the two lines meet and make a right angle? Do you think it's these two that make a right angle here? Do you think it's these two that make a right angle here? Not this right angle. This is the one for the rectangle. I'm talking about the triangle. Right there, do they make a right angle? Or is it these two that make a right angle? Okay. And if you look, if you pay attention, you can see that these two lines are the ones that meet and make a right angle. So that's my base and height, or base and height. It doesn't matter which way you see it, but it's one's the base and one's the height. Divide by 2 to get the answer to this one, and add it to this answer over here. Okay. Here, number 6, you have here is a, I can see there it's a square. And why do I know it's a square? Because if this is 10, across it is 10, and if this is 10, across it would be also 10. So that's why we have a square. A square is just base times height, plain and simple. Okay, we also have some kind of circle, or part of a circle. Okay. So we do have part of a circle there. I have this here. That's not a full circle. That's part of a circle. And does it tell you how much of a circle do you have? And let's see here. It doesn't say what kind of how much of a circle you have. But think about it. If I completed my circle, it would be that. Obviously, I don't even have half of a circle. Okay, obviously I don't. Okay, if you think about it, you have 1/4 of a circle. 1, 2, 3, 4 sections, but you only have 1/4 of it. So what you have is this, pi times radius squared divided by 4. Because you have one section, so you need to find each section. We're going to use pi as 3. Okay. So this is the center. Going out is 10. So obviously that is the radius. Okay. And so input it into here. Solve this, and your answer, add it to the answer of the square. Obviously 10 by 10, that's 100. So 100 plus whatever that gives you. Okay, number 7 there. If you look at the composite figure, it says the rectangle is 15 by 7 inches. So let's put the rectangle 15 by 7 inches. Okay, 15 by 7. The two congruent squares, and it says the two congruent squares have a side length of 5 inches. So we're going to say the two congruent squares, so these have a measurement of 5 on each side. So all sides are 5. Okay. And so that means that, well, a square is equal to base times height. This one is also base times height. And the rectangle, which is what I'm going to trace right now, this is the rectangle. That one you also find by doing area equals base times height. Okay. So all you got to do is find the area of the rectangle. Okay. And subtract the two spots here, which are triangles. Okay. Okay. So there's a few ways you can do this. Okay. You find the area of the rectangle, and you subtract half of the square. Okay, which makes one triangle. This is another half of the square, makes another triangle. Okay. And so you think about it, there's a few ways you can do it. Okay. Think about what you can do here. Okay. And how to solve it. Remember, you only want this piece, not the whole square here, just half of the square. And you only want half of this square. And these two you're going to subtract from the area of the rectangle. Number 8, you have composite figure gives you measurements. CF is 6.2. CF is the one that's coming down. Obviously, that's going to be a height. AE is equal to ED. So AE is equal to ED. Those are both 8.4. Okay. And so if I make a line here, what does that measure? Well, if it's congruent to this guy, that means it has to be the same. So just think, those two have to be also congruent. And what do you have here? You have a triangle, base times height divided by 2. You have a parallelogram, base times height. Find the answers to both of these and add them together. A composite figure here, you have a semicircle and an equilateral triangle. So you have a semicircle and an equilateral triangle. Equi means the same, so that means that all sides are the same. And so now this, it's telling you that it's 12. And so that means that all these are 12. So each side is 12 here. So obviously you're going to find the area of a triangle. Base times height divided by 2. That's the triangle in the middle. Base times height. Okay. Base times height. Okay. What does this measure? It's telling you if they're equilateral triangles, that means all sides are the same. They're all 12s. So your base is 12. That's what you're going to put here. Okay. So 12 right there. The height is given to you, 10.4, right there. So 12 times 10.4 divided by 2. And for the circles, you're going to use the half circles or the semicircles. You're going to divide by 2. And so what you get the answer here, it'll be for each half circle. Okay. Now if it's all the way across, remember if I have my whole circle like this, if it's all the way across, is that the diameter or the radius? So find the diameter and the radius. Okay. Remember on the other side I put a picture. This is the diameter. This is the radius. Okay, so use this equation to find the answer to each of these half circles, and then each answer you add them. All four faces you add them together. Look at the composite figure here. The figure consists of a rectangle and 3 congruent circles. Okay, so now we have area of a rectangle. Of a rectangle and 3 congruent circles. Which of the following best represents the area of the rectangles not contained in the circles? So you want the area of the rectangle not contained in the circles. So that means not contained in the circles. So that means you want this piece, this unshaded part. That's what you want. Well, first you got to figure out what this measures. And to do that, you got to think there, okay? If these are all congruent circles, that means that the diameter of each one is the same. So what would be the diameter for the total to be 24? And the diameter has to be the same. That means this measurement is the same as this measurement is the same as this measurement. So that means if this is 24 total, each one should be 8. Because 8 plus 8 plus 8 is the 24. Okay. And so what does this measure here? Well, this is also considered the diameter if I go across this way. Okay, it's the same. I'm going across from one end to the other end, crossing the center. So this is also my diameter, which is the same as this. So that means that if this is 8, this is also 8. And so that is my diameter. My diameter is 8, but it happens to be also the height of the rectangle. Okay. So that means this is the base, this is the height, which is 8. So we're going to do area is equal to base times height. Base times height. And then we do the area of a circle, pi times radius squared. For pi, we're going to use 3. And don't forget this is pi times radius. Okay. When you get the answer to this one, 24 times 8, you're going to get an answer here, which is what? 3 times, what's the radius? If the diameter is 8, the radius is 4. So 3 times 4 times 4. 3 times 4 is 12. 12 times 4 is 48. So that means that this is a 48. That means each circle is 48. Remember, each one, not all 3 together. Each one is 48. So think, if each one is 48, 48, 48, 48. You subtract that from the area of the whole rectangle. Okay, hopefully this helps you. Adios.